Let's get down. Get up.
We have the differential equation 2/5 x double prime plus kx equals 0. And this describes some sort of simple harmonic motion. We're told that our initial position is 2, and our initial derivative of the position is equal to the initial velocity. And we're told that the period of the motion is pi over 2, and the amplitude is equal to 2. We want to know what the spring constant k is and what the initial velocity v naught is. So to find out what k is, first we can find out what the frequency of the system is. The frequency is equal to 1 over the period. 1 over the period, so 1 over t. That's going to be 1 over pi divided by 2, which is 2 over pi. 2 pi times the frequency is equal to the angular frequency, in this case omega naught. So that means our angular frequency is equal to 2 pi times 2 over pi, which is equal to 4. Our angular frequency is defined to be the square root of k over m. So that means the angular frequency squared is k squared over, or sorry, not k squared, it's just k over m. So k equals m times our angular frequency squared. To find m, we look at our differential equation. The differential equation should be m x double prime plus k x equals 0. So that means 2/5 is equal to m. So write that m equals 2/5. So that means k equals 2/5 the angular frequency squared, which is 4 squared. So this is 2/5 of 16, or 32/5. So that is our k. And now we got to find our initial velocity. We can do that by writing down the form of the solution. For simple harmonic motion, that is going to be x of t equals a cosine omega naught t plus b sine omega naught t. We know omega naught is 4, so this is a cosine 4t plus b sine 4t. We know that if we plug in t equals 0, we get x of 0 equals a cosine 0 plus b sine 0. This goes to 0, so that means, and cosine 0 is 1, so we find that the initial position is equal to lowercase a. We're told that the initial position is equal to 2, so we know a equals 2, so our x of t is equal to 2 cosine 4t plus b sine 4t. We take the derivative of this, x prime, we find that that equals negative 8 sine 4t plus 4b cosine 4t. If we plug in 0 for this, we get negative 8 sine 0 plus 4b cosine 0. This goes to 0. Cosine 0 is 1. We're told that x prime of 0 is equal to the initial velocity. So the initial velocity equals 4b. That gives us b equals the initial velocity divided by 4. Now if we use the relation a squared, the amplitude is equal to lowercase a squared plus b squared. We're told the amplitude is equal to 2. So we have 2 squared equals a squared. A squared is, lowercase a is 2, so that's going to be 2 squared. And b is v naught over 4, which we found over here. So 2 squareds will cancel from both sides, giving us 0 equals the initial velocity over 4 squared. If we square the top and bottom of that and multiply both sides by 16, we get v, the initial velocity squared is equal to 0, so the initial velocity must equal 0.
Oh my dog, get up.